Hello friends, welcome to Silicon VLSI. Today we will discuss about which metal layer has a higher capacitance value, the lower metal layer or the higher metal layer. So this is our topic. Before that, I just want to explain you what is the metal stack in our VLSI design or VLSI layout. So you can see here the lower metal means M1, M2, M3, M4, M5 and the higher metal means WB, WA like this way. So each technology has a different metal stack and in a technology itself has a different metal stack if you observe in your layout. So this is base layer, base metal. So if you notice here from M1 to M5 thickness of metal is same, from B1 to B3 thickness is same, E1 to E2 thickness is same. Do you know why it is? If you know, just do comment, or if you don't know, just do comment. I will let you know in my next video. So yes, so lower metal means M1, M2 and the higher metal means topmost metal. So next, now we will see the capacitance, how it is there in layout, like which related to metal capacitance and the metal to substrate capacitance. Here this capacitance is very important thing, metal to substrate capacitance. It is a very important thing which we don't consider in our layout design. So this we already know metal to metal capacitance, we already know, but the metal to substrate capacitance also plays a significant role in a layout design, in especially in a lower technology node like 7 nanometer, 5 nanometer, 3 nanometer. This capacitance is a very dominant capacitance. So that's why I will discuss about which capacitance is more. And I think you will get you already get to know what I am talking about. So metal to metal capacitance is this occur between adjacent metal layer. Metal to substrate capacitance is happen between metal and to silicon substrate. So if I do draw the cross section of NMOS, it will look like this. And this is a P substrate. This is via. And now I will draw the metal on the top. This is metal 1. This is also metal 1. This is N plus. This is N plus. This is P sub. If this is M1. So if you see, and somewhere metal, top metal will come on the top side here. In between via is there. So if you notice here, M1 is very close to the substrate. So we have a capacitance formula epsilon 0 A by D. So right now M1 is very close to substrate. So there are two kind of capacitance will play important role for M1. If you see this top metal, it is very far from the substrate. So it has a less capacitance. So overall what I am into say is lower metal like M1, M2 are much closer to the silicon substrate. Due to this proximity, metal to substrate capacitance significant higher, as I explained earlier, previous slide. Additionally, lower metal layer tend to have a smaller width and the pitch. It is also help to increase the parasitic capacitance with adjacent layer. There are two factors for M1. Is its width and height is thickness is also very small. So it is also play a significant role. And for a higher metal like M7, M6, are farther away from the substrate and they experience much lower metal to substrate capacitance. And especially they are also wider and spaced farther apart compared to the lower layer, reducing the metal to metal capacitance. So this is how we can say in conclusion. So if any interviewer asks you which capacitance is more, so you have to clearly say that lower metal layer has a higher capacitance as compared to higher metal layer. If they ask you reason, you just need to explain him or them like why lower metal layer has a higher capacitance. You have to give two things. One thing is metal to substrate distance is very small. So substrate capacitance also plays significant role. So in this lecture, so substrate is important thing to explain them. Substrate is play very important role for a base metal. So that's why for a critical signal, we always choose higher metal like M2, M3. If you don't know, like you can do the one experiment. You draw, like let's assume your layout is LVS and DRC clean. You run the extraction. Now, for your experiment, if you route particular sensitive signal with M1, you just try to make to jump in M3, and then you compare that extraction results, like you coupling cap or coupling like clumped or coupled RC. You will see the difference. This is occur in lower technology now, especially in lower technology. So our advice is for sensitive signal, you better to routing in metal 3 or top metal, like I cannot set top level because top level is really occupied for the power in ground signal. So better to routing in M3 instead of M1. So this is how this lecture is end here. So if you have any question related this, please do comment. If you want to know about metal stack or how many metal stack is there, how metal stack will behave, why we need that metal stack, different metal stack, you can do comment. Thank you so much. If you want more detail, please visit our website called siliconvlsi.com. If you like this video, please subscribe. Thank you.